We will be illustrating how to analyze simple linear regression data using StatCrunch. First, we have to load our data, which is stored on our computer in an Excel file. So under Data, we're going to pick Load Data from File. The file is located on my computer. We're going to browse to find the file. We're going to be using the systolic blood pressure data that was mentioned in the PowerPoint slide. And we are going to load that file. So here in the first column are the age of our subject, and in the second column is the systolic blood pressure of our subjects. To analyze this data, we are going to go under Stat, and we're going to select Regression, Simple Linear. Let's do that again. Stat, Regression, Simple Linear. Our X variable is age. Our Y variable is systolic blood pressure. If I would like to predict the systolic blood pressure of someone who is 30 years old, I can click that box. I always like to save both the residuals and the fitted values. And I always like to plot the fitted line. So on this screen, we have a few very important pieces of information. We have the simple linear regression equation itself that says that systolic blood pressure is 98.7 plus 0.97 times a person's age. So the y-intercept is 98.7 and the slope is 0.97. The sample size was 30. The correlation coefficient was 0.65 and R squared, or the coefficient of determination, was a 0.43. Almost all of the rest of this information is not relevant for this course. However, if you look down at the bottom table, you will see that a 30-year-old person would be expected to have, or predicted to have, a systolic blood pressure of about 127 or 128. All of this information, of course, could be exported by hitting the Options button. What I'm going to do is I'm going to hit the next screen. And here we see that on the next screen we have the fitted line plotted on our scatter diagram. If we'd like, we can hit Options and export this graph. One of the things that's kind of interesting about this data set is what seems to be an outlier. This person, who is somewhere in their late 40s, has an incredibly high blood pressure for their age. I'm going to get out of this, and I'm going to look at what happened to our original data. Two columns have been added to our original data. A column of residuals that measures the distance that the point is from the fitted line, and also the fitted or predicted values. So if we look at this first subject, who is 39 years old, who has an observed blood pressure of 144, their residual is about a 7.4, meaning that their blood pressure was 7.4 units higher than expected. The predicted value was only 136, and that subject actually had a blood pressure of 144. So let's scan our list and look for somebody with a negative residual. This 42-year-old person had a blood pressure of 124. The predicted value for someone that age was 139. So their blood pressure is 15 units lower than predicted based on their age. Let's see if we can go down and find that seeming outlier, that person with a very, very high residual. Well, I see somebody there with a residual of 18. That 44-year-old person actually has a blood pressure of 160, and the predicted value was 141 based on their age. So based on their age, that person has a blood pressure that is 18.5 units higher than we would have expected. Here's our person with a really high residual. The 47-year-old person with a systolic blood pressure of 220, when the predicted value for someone who is 47 years old is only 144. That person's blood pressure is 75 units higher than would have been expected based on their age.